Pravesh Malviya. In the last lecture, we discussed about transformer. Now we will be understanding the operation with the help of an animated video. So, a transformer is an electric machine that is used to transfer electrical energy from one circuit to another circuit without changing its frequency. The frequency does not change at all instances. Whatever frequency you feed to the input side, you will get the same frequency from the output side. So a transformer looks like this. A transformer has various parts. It has two tanks. The one is conservator tank and the another one is main tank. It has few terminals also where we can connect the transformer to external circuits. So these terminals are known as bushings. Few bushings are large in size and few are small in size. It is because of their voltage rating. And for the temperature, to maintain the temperature in certain limit, we have fins for cooling of the oil. It flows through a coil of alternating nature. It set up an alternating magnetic flux around the coil. This is about a single turn only. Now if we have several turns in the winding, several turns in the circuit, so what happens? The magnetic field becomes very strong. So here there are so many turns in the winding, and if alternating current flows through the entire winding, there will be a flux will be set up and it will be of alternating nature. This is how it is explained, that when a wire carries current and how does the magnetic field set up around it. So when a winding carries alternating current, it sets up a alternating magnetic flux around it, and when this winding is wound over limb of any core, it sets up magnetic flux in the core also. So here we can see that the winding, this is the winding which is wound over the limb of this core, and alternating current is flowing through this winding. Now what happens? Whenever the alternating current flows through the winding, it sets up a magnetic flux, and that is of alternating nature. So this alternating magnetic flux has now got a path to flow. So this entire rectangular path is the path of magnetic flux which will be flown through this core. And during this path, on this path, there is another winding. It is known as the stationary winding. So what happens when primary winding is supplied with alternating current? Then the magnetic flux will flow through this entire path. This is the magnetic core. And we know that when across any stationary conductor the magnetic flux continuously varies, it results in induced EMF across the terminal of the conductor. So this coil we can consider as a stationary conductor. Now across this stationary conductor, this magnetic field is continuously varying. You can see that this flux is sometimes it is flowing in clockwise direction and sometimes it is flowing in anti-clockwise direction. So this variation of magnetic flux around this stationary conductors create an EMF across its terminals. So this is the mutual induction effect. Because of this, an EMF is induced around the terminal of the secondary winding. EMF will be induced in the secondary winding depends on the number of turns in the secondary winding. So if the number of turns are higher in the secondary windings, EMF induced will also be higher, and if the secondary winding has a lower number of turns, the EMF induced will be also lower. So on this basis, the transformer can be of two types. It can be step up and step down transformer.